Hello everyone, welcome to another video on theorems. In this video, I will discuss Thevenin's theorem, which is most commonly used theorem for circuit analysis. In previous videos, I had discussed three different methods for analysis of circuits. I started with mesh analysis, then I had discussed nodal analysis, followed by superposition theorem. This Thevenin theorem is the most important theorem among all. The reason for that is many times we are interested in analyzing the response across a certain load. We are not interested in analyzing the whole circuit. We want to find out the current through a specific resistance, or we want to find out the voltage across a certain resistance. In that case, it is more useful to go with Thevenin's theorem in comparison to other methods. More specifically, if that load resistance, the resistance through which we are finding out the current or across which we are finding out the voltage, if that one is variable, then the most suitable method for analyzing that circuit is Thevenin's theorem. Now, the statement of this Thevenin theorem states that for any linear electrical network containing voltage sources or current sources and resistances can be replaced across its terminals AB by an equivalent, which is combination of a voltage source in series with a resistance. The condition for this is we need linear electrical network. Now what this statement means, I will show it by drawing a circuit. And let's say we have this circuit. These are terminals A, B. In between these terminals have a resistance denoted by RL, and let's say it is a variable resistance. If I am interested in finding out that what is the current through this resistance, then for nodal analysis I need to write one equation and I have to solve that. For mesh analysis I have to write two equations and then I have to solve that two equations simultaneously. Now if we have multiple values of RL, let's say we have 10 different values of RL, then we have to write nodal equation 10 times and then solve that equation to find out that what is the current through this resistance RL. And if we go with mesh analysis, then we have to write the mesh equations, two mesh equations 10 times, and then we have to solve them again and again 10 times to find out the current through resistance RL. In such cases, when we are interested in analyzing circuit for a particular resistance, it's more suitable to draw the Thevenin equivalent of this circuit. We can have single voltage source, we can have multiple voltage sources in this circuit, or we can have combination of voltage sources and current sources and resistances. Like except this load resistance, the whole circuit can be replaced by a single voltage source, which is denoted by VTH, in series with resistance RH, and here we have terminals AB, and then we can connect the load resistance as it is over here, We can find out the current. Now we can write the expression of IL as VTH upon RTH plus RL. So even if we have 10, 20 or whatever the multiple values of RL, we just need to solve this equation again and again, because once a Thevenin equivalent is drawn, that will remain same until unless we make any change in this circuit, the circuit which I have shown in this dotted area. Now the question is, what is VTH? VTH is open circuit voltage across load terminals. VTH is open circuit voltage across load terminals. Now open circuit means we need to remove the load resistance, and then we need to calculate that what is the voltage between these two terminals. Like particularly for this circuit, if I have to find out VTH, I need to redraw the circuit again. V1, R1, R2, R3, then we have terminals A, B. Since it's open circuit voltage, so I have opened the load terminals. Then we need to find out the voltage over here. We assign the polarity of this VTH randomly. Now we need to find out the potential difference between these 2 points. Now particularly for this circuit, the current through R3 is 0 since these two terminals are open. So there is no voltage drop across R3. So whatever the voltage is there across resistance R2, same is the voltage between terminals A and B. So in this case we need to find out the voltage across resistance R2. So VTH, which is actually open circuit voltage, in this case it is equal to voltage across resistance R2, which we can find out by using voltage division rule. And according to voltage division rule, it's source voltage, that is V1, into resistance across which we are finding out the voltage upon sum of the resistances which are connected in series. So it's very simple. But how to find out this open circuit voltage? It changes with every circuit. We don't have any specific formula for this. We always need to find out the voltage by open circuiting the load terminals. So there are different possible combinations that how we need to find out VTH. Then coming to second element, that is RTH. RTH is equivalent resistance seen from load terminals. Equivalent resistance seen from load terminals. So again we need to remove the load resistance. So we have resistance R1, R2, R3, RL should be removed from the circuit, and we have a voltage source over here. Now if we have a independent voltage source is there, then that voltage source has to be replaced by a short circuit, and if we have any independent current source, that will be replaced by open circuit. And if we have dependent source present in the circuit, then we can't replace them by open circuit or short circuit. Therefore, the method for finding RTH is different when we have dependent sources present in the circuit, that I will discuss in the coming videos. Firstly, focus that how to find out RTH when we have only independent sources present in the circuit. Now this is the equivalent of the circuit by removing RL and replacing the voltage source by short circuit. Now we need to find out the equivalent resistance seen from terminals AB. So now when we need to find out RTH, we have to start from the opposite side. So from here when we start, R1 and R2, they are in parallel. The resultant is in series with R3. So RTH is R1 is in parallel with R2 and their resultant is in series with R3. So again, how to find out RTH? That varies from circuit to circuit. It's not always same. So this is a basic about Thevenin, that what is VTH and what is RTH. Now let's take an example to understand it better. Problem is find the current through 2 ohm resistance using Thevenin's theorem. For the figure shown below, now I am drawing the circuit. Now through resistance R2 between terminals A and B. This is A and this one is B. So it means we need to find out the current through this resistance using Thevenin's theorem. It means this 2 ohm resistance is actually load resistance. This one is load resistance. Now what we need to do? We need to replace this circuit by its Thevenin equivalent VTH in series with RTH. Then we will have terminals AB where we will connect 2 ohm resistance and then find out the current through this 2 ohm as VTH upon RTH plus 2. So now let's find out VTH. For calculating VTH, let's draw the circuit. These terminals A and B, they should be open circuited because this 2 ohm resistance that should be removed from the circuit as it's a load. So these are the different resistances. We need to find out voltage over here. Let's say this is the assumed polarity. Now how to find out this voltage? It's now our choice. We can apply any method whichever is convenient. We can apply nodal analysis by considering this as one node, this one as reference. Find out that what is the voltage over here. Then we need to find out the current through this branch. We need to find out the voltage over here. You can go with this method, or you can simply apply mesh analysis by assigning I1 current to this mesh, I2 to this mesh, and then VTH can be found by applying KVL to either this open loop or this open loop. So we will write that equation later on. Firstly, let's find the value of current I1 and I2 which we need for calculating VTH. So when we apply KVL to first mesh, starting with this 2 volt source, -2, then drop across 2 ohm resistance plus 2I1, drop across this 12 ohm resistance plus 12 into I1 minus I2 equal to 0. So this will give us first equation 14I1 minus 12I2 equal to 2. This first equation. Now let's move on to mesh 2. Assign the voltage drop polarity for mesh 2 resistances plus minus plus minus plus minus. Starting from this 1 ohm resistance, it's 1 into I2, then 3 into I2 plus 4 plus 12 I2 minus I1 equal to 0. This will give us second equation as minus 12 I1 plus 16 I2 equal to minus 4. The simultaneous solution of these two equations will give us the value of I1 and I2. I1 comes out to be minus 0.2 ampere and I2 is minus 0.4 ampere. Now question is we need to find out the value of VTH. For that, let's choose this path. So if we choose this one, starting from 3 ohm resistance, we have 3 into I2 plus 4 minus VTH. Since we have considered terminal B as negative, A as positive, negative sign came first, so it's minus VTH. This is equal to 0, which will give us VTH as 3I2 plus 4. Now using the value of I2, 3 into minus 0.4 plus 4, we get the value of VTH as 2.8 volts. So this is the first step. Then second step is we need to calculate RTH. For calculating RTH, we again need to draw the equivalent circuit by removing the resistance RL, and all independent voltage sources will be replaced by short circuit. So firstly we have 2 volt source that has to be replaced by short circuit, then 2 ohm resistance, 12 ohm resistance, 1 ohm resistance. Here we have load resistance which we need to remove, 3 ohm, 4-volt source again replaced by short circuit. We need to remove this load resistance and we need to find out RTH, that equivalent resistance seen from here. So what we see, 12 and 2 ohm, these two they are in parallel. So we have parallel combination of 12 and 2. It's now connected in series with 1 ohm. Here A, this one is terminal B, 2 ohm resistance again. Now 12 and 2's parallel combination is in series with 1 ohm, and this whole combination that is again in parallel with 2 ohm resistance. Now you can easily see it as that if any current will flow from here, it will get divided into two parts. That's why they are in parallel, while this current which is flowing through 1 ohm resistance, same will flow through 12 and 2 ohm parallel combination. So RTH is 12 in parallel with 2 in series with 1 ohm, and this combination is again in parallel with 3 ohm resistance. So when we solve this, we get the value of RTH as 1.425 ohm. We had already written the formula to calculate I2. I2 ohm is VTH, which is 2.8 upon RTH 1.425 plus 2, which will give us the answer of current through 2 ohm resistance as 0.818 ampere. I'm taking one more problem so that you can have more practice. Find the current through the 10 ohm resistance using Thevenin's theorem. Now for this problem, the circuit is having two sources. One is current source while the second one is a voltage source. This is 10 ohm resistance, which is actually load resistance. Let's say this is terminal A and this one is B. We have to replace this by Thevenin equivalent VTH in series with RTH. Then between A and B, we have to connect the load resistance, that is 10 ohm. So we need to calculate VTH as well as RTH. For calculating VTH, let's draw the circuit again. Now this load resistance that has to be removed from the circuit. Let's say this is the assumed polarity. Now, how to find out VTH? That can be found if we know that what is the current through this 5 ohm resistance and what is the current through 20 ohm resistance. In this circuit, if we look, this 10 ampere will flow through this 5 ohm resistance only. So current through 5 ohm resistance is 10 ampere flowing in downward direction. While we need to find out the current through this 20 ohm, sorry, this one is not 20, this one is 30. We need to find out the current through this 20 ohm. Let's say this one is I. We can apply KVL in this mesh to find out the value of I. So it will be 30 I plus 100 plus 20 I equal to 0. I will be equal to minus 2 ampere. Minus 2 means current is actually flowing opposite to the assigned direction. So we can say current is 2 ampere current is flowing in downward direction, since according to our assumed direction it was upward. So we found the current through 20 and 5 ohm resistance. Now let's apply KVL in this open loop. We can apply KVL to the open loop since we have assumed that the voltage across this open circuit is VTH. We had already assumed the polarity of this VTH as well. We have considered terminal A as positive, B as negative. So I will start with VTH only. So plus VTH. Then as per the direction of 2 ampere, this will be the voltage drop polarity. So plus 20 into 2. Then according to direction of 10 ampere, this will be the voltage drop polarity. Now negative sign is coming first. So minus 5 into 10 equal to 0. So VTH will be equal to 50 minus 40, 10 volts. The next point is we need to find out RTH. For calculating RTH, we need to draw the circuit again. The current source of 10 ampere has to be replaced by open circuit. Then we have 5 ohm resistance. Load resistance has to be removed from the circuit. 20 ohm, 30 ohm, and this voltage source is replaced by short circuit. This is RTH. Now, what is RTH? 20 and 30 they are in parallel, and then the resultant is in series with 5 ohm. So RTH is series combination of 5 and with 30 and 20's parallel combination. So which will give us the value of RTH as 17. So we get the Thevenin equivalent as 10 volts, 17 ohm, and here we have the load resistance 10 ohm. So I 10 ohm will be 10 upon 17 plus 10.37 ampere. So what we have seen in these two problems, that how to calculate RTH, it depends upon the circuit. How to calculate VTH, that is also dependent upon the circuit. We don't have a specific formula for calculating VTH and RTH. We need to understand the concept that what is the meaning of VTH and what is the meaning of RTH. and accordingly we can calculate them for different circuits. I will take few more problems on Thevenin's theorem in next video, and if you have any doubts you can ask me in the comment section. Thanks for watching this video.